Good morning, guys. The infamous test 3. Okay, I don't have a whole lot of review. We're just going to get right into the problems that y'all had on your test. We have trig equations. I've solved a variety of different ones. So go through and look at them. I'm not going to go through everything detail by detail, but I am going to go through a few of them. So in the basic ones, what we're going to do is we're going to get our trig function by itself. In this case, whenever I solve for the cosine of theta, I got -3 over 3 square root of 2, or -1 over the square root of 2. So you really have to know where your trig functions are positive and negative. My cosine graph follows the x-axis, so it's negative in quadrants 2 and 3. And -1 over the square root of 2 is a 45-degree reference angle. So we're going to get 3 pi over 4 and 5 pi over 4. This next one here, the one thing I want you to watch out for is it's a sine squared. So when you take the square root, you have to take both the plus or minus square root. So it's plus or minus 1 over the square root of 2. So we get all of our 45-degree angles for this answer. I tried to outline the answer in orange. Okay, here's one where we don't just have sine of just theta. So anytime we don't have just theta, we need to solve it like it is just theta and then take it a step further. So for instance, we solved this one for the square root of 3 over 2. Where is my sine of theta, the square root of 3 over 2? Well, it's at pi over 3 and at 2 pi over 3. Sorry, I didn't write it there. But remember, we're not looking for just theta. We're looking for what they have is 2 theta. So we write it in general form because remember, it's pi over 3 plus 2 pi plus 2 pi. We could go on all day long. But they only want all the thetas between 0 and 2 pi. So what I do is I write both angles in general form. I get pi over 3 plus 2 pi k, and I get 2 pi over 3 plus 2 pi k. Then I solve it for whatever is in the parentheses. In this case, it's 2 theta, so I solve for theta. I divide everything through by 2, and I get pi over 6 plus pi k and pi over 3 plus pi k. Then I make k 0, and I have to make k 1 in this case. So I plugged everything in. K equals 0 is just pi over 6. K equals 0 here is just pi over 3. Then I make k 1, so I get 7 pi over 6. And I make k 1 here, and I get 4 pi over 3. Okay, I'm skipping the next one because we did it already, some similar. The next one is the calculator problem. Believe it or not, these are more challenging than the other problems. So I solve for my tangent of theta, and I get the tangent of theta is -9 over 5. So I type it in my calculator as an inverse. Tangent inverse -9 over 5. And this is the answer I get, -1.06. But notice, where's the interval that they want the answers in? They want between 0 and 2 pi, because they should give us a negative answer. That's where our tangent inverse is defined, but that's not where they want our answers. So for tangent, what you do is you move the reference angle into the defined quadrants. So if my tangent is negative, where is a tangent negative? In quadrants 2 and quadrant 4. So what I'm going to do is I'm going to move this reference angle into quadrant 2 and then back around into quadrant 4. And you can use geometry to figure it out. This case, I could either do pi minus the 1.06, or the beauty of the tangent and cotangent functions is they just repeat every pi, so you can just add pi twice. So if I add pi once, I get 2.08. Notice if you would have calculated this by doing pi minus the 1.06, you would get the same answer. And I can add pi again and get 5.22. Or I could have said, well, this is the same thing as 2 pi minus the 1.06 and get the 5.22. So just think of it as moving the reference angle into the correct quadrant. Okay, I'm going to keep going with these trig videos, solving equations in the next video.